in this video I'm going to show you how to analyze a sound using Logic Pro X. So what I've got here is my sound file in an audio region. If I double click on that, I can see that it's a stereo file, the left channel above, the right channel below, and that's just the editor window there. Now to be able to analyze the sound, there's some settings I'm going to need. First off, I want to view time up here. So if I change my display bar to set to time, and then this is going to demonstrate time in minutes, seconds and milliseconds. If yours isn't showing milliseconds, it might be showing samples. So to change that, you just go to Logic Pro X, Preferences, go to Display, and then you make sure at the bottom it says Display Time As, and you want to set milliseconds, not samples. Okay, so now the display bar is displaying seconds. That's going to be really useful when we measure parts of the sound in the ADSR envelope. First thing we're going to look at is what is the pitch of this sound. So if you have perfect pitch, brilliant, then you'll know exactly what it is. But if you don't, here's how you can work out what the pitch of the sound is. So we're going to open up the inspector and we're going to go to Audio Effects. We're going to go to Metering, Tuner, and then this will tell us the pitch of the sound. So let's have a listen. So we have an F. What I'm going to do is I'm going to keep a log of all the notes in the notes section. So pitch, we have an F. Okay. So the next part I'm going to look at is the ADSR. That's the attack, decay, sustain and release. So for that, I'm going to need to open up this sound. And to make it easier for myself, what I'm going to do is I'm going to enlarge the waveform by clicking on this and zooming in until the tops of the waveform get to 100. I'm just going to zoom in a little bit more. Now, as it's a stereo file, there's going to be a file for the left and a file for the right. So just pick one if they're similar, and we'll work with that one. So we're now looking at the ADSR. The attack, decay, sustain and release of the sound. That's referring to the amplitude over time, the volume of it over time. So I can see straight away here that the sound goes from silence at this point here to its loudest point at this point here. So to work out how much time that takes, we can just use some basic maths. So the attack phase finishes at 109 milliseconds. And it starts at 0.99, so 99 milliseconds. So it takes it 10 milliseconds. But if you're not good at maths, you can just open up the spot view here, and then we can type in 109 minus 99, and it gives us 10. So we know that the attack phase takes 10 milliseconds. That is from silence to its loudest part. Now let's just zoom out. Okay, so the next part of a sound is its decay phase. Now this sound only has an attack and a decay phase. It doesn't have any point of sustained volume, so it makes it easy to work out. So the decay phase starts at the end of the attack, which we had before, at 109 milliseconds, and it ends over here at 21,125. So it's going to be a 20-second decay. But let's just put that in again. So it's 21 seconds, 125, minus 109. And it gives us a decay phase of 21 seconds and 16 milliseconds. There is no release on this sound. It hasn't been cut short at any point, and there's no sustain. So let me just write that down. So the ADSR, the attack was 10 milliseconds of attack, and the decay was super long. Milliseconds. There is no sustain, and release hasn't been used because it's a long held note. Okay. So we've got the pitch, we've got the ADSR envelope information, and now I'm going to be looking at the frequency content of the sound. So for that, I'm going to need to bring up the equalizer. And I'm just going to change some of the settings to make it better. So I'm going to click over here and set the decay to really quickly, 30 dB per second. So that means it's going to be really fast and accurate. So let's have a listen to the sound with the analyzer on. What I can do over here is zoom in by bringing this side up so I can see what's going on in the lower amplitudes. Okay, so I can see there's clearly harmonics in this sound. There's a clear fundamental here, which is the harmonic on the left hand side, and then there's a range. So now what I'm going to do is I'm going to do the whole thing again, but I'm going to set the analyzer decay down from 30 dB to 0, so it will take a still frame of the sound over time, play it through, and then I can pause it. And now Analyzer will keep it locked. So here's what it's telling me. The frequency content has clear harmonics, clear spikes, and there's lots of them, and they tail off from 1 kHz and they decrease. You can see that there is a blue line and a light red line underneath, and they are just slightly different of each other. The blue line is the center channel, while the red line is the stereo, the sides. So what that tells us is that there is some slight difference between what we're hearing on the left and the right channels. So the shape of the harmonics is flat until 1 kHz. Now to see if it has integer or non-integer harmonics, what I'm going to need to do is find out the frequency of the fundamental. I'm going to turn on one of these dots and slide it up to the note with the mouse, and it's telling me that it's at 86.5. So if the second harmonic is at 172 Hz, so I'm just going to turn on one of these curves and slide it up to the note, and yeah, we can see that it's at 173. So we know that the first harmonic is at a whole number multiple of the next one. So we know that it's integer harmonics. So let me get rid of those and write integer. From this, we can see that it's clearly all harmonics, so there is no noise content. So I can get rid of this part here. And there is a slight difference between the center channel and the stereo because of this white line and red line. This will be really useful when we're setting up stereo spread in the synthesizer. So now let's have a look at the last thing, which is change of harmonics during the decay of the sound. So as the sound goes from the start to the end, do the harmonics stay the same or do they change? So I'm going to need to put the analyzer decay back to full settings so it reacts really quickly, and let's view the sound. So we can see as the sound decays, the upper harmonics lose their amplitude, they become quieter. Let's view that again. So these harmonics here died away quicker than the fundamental, which actually gained volume. So, change of harmonics during decay, there was a decrease in the upper harmonics. And that's everything that we're going to need to be able to recreate this sound.